So today we're going to learn about cube roots. We've already learned about square roots and we've realized that everything about square roots are twins. So if I wanted to take the square root of 36, our answer is 6 because 6 times 6 is 36. So for example, on this problem, and we're on page 7 in our packet, since 11 times 11 equals 121, then, oh, there's a typo, then the square root of 121 is 11. We're looking for two identical factors. This is what we did in square roots. So if I wanted to say take the square root of 25, our answer would be 5. And the reason is because 5 times 5 equals 25. Again, always looking for two identical factors or twins when dealing with square roots. The new thing we're going to learn today are what are called cubed roots. And cube roots are three identical factors because with a cubed root, you're thinking of three, or triplets, I guess we could say, triplets that multiply to get that number. So we find cube roots in the same way, except we need three identical factors instead of two. The symbol for a cubed root looks like this. You can see that it's different than the squared root up here because this one does not have a number here. That number is called an index. And with square roots, they're so popular, they don't even need it. If you see that, you just know, oh, it's a square root. If you see a teeny tiny little 3 there, that's saying, oh, we want the cubed root of that number. So in your head, you have to think, what times what is 8? But those numbers all need to be the same. So you need three identical factors or triplets. So we know that 2 times 2 times 2 is 8. So therefore, the cubed root of 8 equals 2. So that's what we're going to be working on today. Eventually, you're going to need to memorize some of these, at least up to 10 cubed, or the cubed root of 1,000. So we're going to take a look at some of these. So if you could go below in your packet, again, still on page 7. We're going to try to look at this forwards and backwards. So we're trying to think, the cubed root of what is 1? So 1 times 1 times 1 is what? Well, it has to be 1. The cubed root of what is 2? Well, we just did that one up there. 2 times 2 times 2 is 8. Therefore, the cubed root of 8 equals 2. Now what about 3? 3 times 3 times 3 is what? So if we have 3 times 3 times 3, well, we know 3 times 3 is 9, 9 times 3 is 27. So the cubed root of 27 equals 3. So you see how you could think about it forward and backwards. Now this one right here, we're trying to think the cubed root of what is 4? Well, we know 4 times 4 times 4 is what? So 4 times 4 is 16. 16 times 4 is 64. So the cubed root of 64 is 4. We can think of it the same way with 5. This one would be 125 because 5 times 5 times 5 is 125. And this one right here would be 216 because 6 times 6 times 6 is 216. So how I'll be asking you these in the future is I will cover this part up and say, tell me the cubed root of 125. And in your head, you have to think, oh, what times what is 125? Oh yeah, it's 5. Or I might say, what's the cubed root of 216? And you'll have to think, okay, what number times itself again as 216? And you would get 6. So you are going to get a little cheat sheet today to help you remember these. But up till about 10 is expected to be memorized moving forward, and they will be on your cheat sheet as well. So you're going to try to get used to doing these so often that they just get stuck there. So the cubed root of 27 is 3. All right, so we're going to flip to page 8 in our packet and do a couple problems together to show you how this would be done. At this point in class, if the substitute has not handed out the yellow cheat sheet, Somebody please politely raise their hand and ask her for the yellow cheat sheet. So this is going to help you work through these problems. So this one right here, they look kind of crazy, right? They're fractions. Well, we're going to do these the exact same way. It's just two problems in one. So let's take a look real quick. Well, I see that's a fraction and that's a fraction. This has a little 3, but this doesn't. So this one's telling us take the square root. This one's telling us take the cubed root. So you have to look out for those because that 3 is really teeny tiny. All right, so let's look at this one. We're going to take the square root of 81. That's 9. And then we're going to take the square root of 225. That's 15. But wait a minute, we have a fraction here, 9 out of 15, and I'm pretty sure that can be simplified. So we have to think, well, what number goes into 9 that also goes into 15 to help us simplify that fraction? And we can actually divide the numerator and the denominator by 3 to get it into simplest form. So 9 divided by 3 is 3. 15 divided by 3 is 5. So your final answer for that one would be 3/5. Now moving on to this one, cubed root of 64 over the cubed root of 216. So we just take those individually. So the cubed root of 64, so again, what times what is 64? That's 4. And again, you can look at your cheat sheet for that. And then the cubed root of 216. What times what is 216? Oh, that's 6. Well, now we're going to look at this fraction. Is it simplified? Nope. We have to divide both the numerator and the denominator by a 2 to simplify it down. So 4 divided by 2 is 2. 6 divided by 2 is 3. So your final answer is 2/3. So this is how we're going to work through any problem that has a fraction. But down below, I've asked you to complete 1 through 6 as your classwork along with a quizzes exercise. But real quick, I'm just going to do one with you. So let's take a look at, say, number 1. We need to find the cubed root of 125. Again, keep in mind, your mind should be going to triplets. What times what is 125? So that turns out to be 5, so your answer is just 5. So it's just like taking a square root, only we're looking for triplets instead of twins. So for your assignment today, you're going to work and finish these out 1 through 6, and then you have a couple exercises to do on quizzes to give you more practice.